HelpMeWithStats.com was used to create this tutorial that can help us calculate a sample size for a given power, one tail. Let's work through a problem calculating the sample size for a given power, but with a one-tailed hypothesis test. The population mean is given as 422 and the population standard deviation is 40. Because there is previous evidence suggesting the mean of the alternative population will increase, we are using a one-tailed hypothesis test with an alpha level of 0.05. If the mean of the alternative distribution is 446, then how many participants do we need for a power of at least 0.8? Since the power of an experiment is the part of the alternative distribution above the critical value of the null distribution, we need to know what the critical value is given the number of tails and the alpha level. With one tail and an alpha level of 0.05, we can look up the critical value and find it to be 1.64. Next, we need to find the z-score, which has 0.80, the power, above z. We use the lookup table to find that a z-score of -0.84 has 0.80 above z. Next, we need to determine the effect size in standard errors, SE. The SE is the distance between the means, but this is also equal to the critical value plus the z-score of the distance between the critical value and the mean of the alternative distribution. The SE works out to 1.64 plus 0.84, which is 2.48. The two distributions are 2.48 standard errors away from each other. Now that we've calculated the SE, we can use that value to calculate the absolute size of one standard error. The standard error is the effect size in absolute units divided by the SE. Here, the standard error is the effect size of 446 minus 422, divided by 2.48, the SE. The standard error works out to 9.6774. Now that we have the size of the standard error, we can use that standard error to calculate the square root of the sample size. From the central limit theorem, we know that the standard error is the standard deviation divided by the square root of the sample size. We can rearrange the terms of this equation to isolate the square root of the sample size on the left side of the equation. Here, the square root of the sample size is equal to 40 divided by 9.6774, which works out to 4.133. It's easy to find the sample size if we know the square root of the sample size. We just square both sides of the equation. N is therefore equal to the square of 4.133, which works out to 17.08. We've rounded this to 2 decimals, because we are going to round up in the final step anyway. We can't use parts of people for experiments, so we always round up to the next integer. In this example, we round 17.08 up to 18. We need 18 participants to have a power of at least 0.8. For more help with statistics, HelpMeWithStats.com is a free website that has more than 70 tutorials, as videos, or as self-paced slideshows. You can also learn how to conduct more than 60 statistical analyses by watching videos that show complete solutions, or by working through an unlimited number of examples using the step-by-step problem solvers. Finally, you can access a comprehensive stats textbook with more than 685 review questions. Thanks for watching. If you find these resources valuable, please share with your friends, teachers, and professors.